In this next video, I'm going to take a look at the development of a truncated cone and a truncated cylinder. This question is not in your workbook, it's from the 2018 paper, section B, question 4, and I'll add a link to this question in Google Classroom. So the question tells us that there's an elevation and end view of a torch. The torch consists of a truncated cone A and a cylinder B, which is also truncated, meaning it has been cut. So I just completed a quick sketch of the truncated cone here. That's what a truncated cone looks like as it's in its upright position, and a truncated cylinder looks like this in its upright position. We're asked to draw the given elevation and end view, and we're asked to project a plan from the elevation. Then we're asked to draw a development of the conical surface A. Then draw a development of the cylindrical surface B. So I've already completed the elevation and the end elevation on a sheet. That's basically orthographic projection that you can complete yourself. I've also divided up the end elevation, the circle representing the face of the torch, and then hidden detail representing the cylindrical surface. So just looking at the back of the question here, I've just completed a couple of sketches, and on the top there, just a reminder that the development of a circle will look like a rectangle. The development of a cone will be this shape here. Okay, when the cone is truncated, or when a cone has been cut like that, the development will then look like this. Okay, so this is where it would normally go if it wasn't truncated up to the apex, but because it's been cut here somewhere, the development appears with a cut line like that. The development of a truncated cylinder then looks something like this, depending on where we start the development from. So in a truncated cylinder we have the lower part of the cut and the higher part. Okay, so we have the lower part of the cylindrical piece that's left and the higher part. So these heights will be represented by here, curving up then to the higher part of the truncated piece, then back down to the joint line. So we begin the question now. I'm going to start first of all with the development of the truncated cone. And I'm going to complete that development over here to the right, just to leave space for the development of the cylinder. Again, I'm not going to complete the plan view in this question. That's something that can be done yourself for revision. Okay, so the first thing we need to do is, with a 4H pencil, we need to draw some construction lines, and we just need to determine where the apex of this cone would be. So remember from class, these lines are called generators, and I'm going to extend the generators, the extreme generators, until they meet this center line. If you didn't have a center line, you just extend those until they intersect with themselves. So this point is the apex of the cone if it weren't truncated. Alright, the next thing I need to do is I need to transfer the points that I've located on the circle. So we have 0 back around to 0, or 1 to 12. If this was, sometimes you'll be dividing up the circle in the plan view and projecting upwards. This time I'm just projecting from right to left. So I've each point projected across nice and light. And what I'm going to do now is I'm going to index these points. So 0 up here at the top, and 6 down at the bottom. This line represents points 5 and 7. This line represents points 4 and 8. 3 and 9 is in the center. 2 and 10 projected across here to the base of the cone, and then up here we have point 1 and 11. Okay, so to draw in some more generators I'm going to draw a line from each one of those points I've determined to the apex. Remember, a cone has an infinite amount of generators, and we just need a few to help us complete the development. Okay, so there are generators drawn in. I'll zoom in a smaller so you can see them. So each one of these generators will pass through the truncated edge at points here. Another one there, here, 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 and these are points that we have already. Okay, now because this generator here and this one here are parallel to the plane behind it, because they're the outermost generators, that is the true length of those lines. So I can take my compass and I can step off the distance from the apex to 0.6 or 0.0, and I'm going to complete this development over here to the right a little. So I draw an arc to represent the development of the base of the truncated cone. Moving back to the elevation, I can now take the distance from the apex to this point here, which will give me the length, the radius of the arc, determining the point or the distance from the apex where the cut has happened. I'm using the same point on my sheet then. I'm going to draw that arc. I'm drawing it a little bit bigger than I need because I'm not too sure where it's going to finish up just yet. Okay. So what I'm going to do next is I'm going to draw in this generator. So from the apex, we'll just call that X to 0. Okay, so I'm going to draw this line from X to 0. So I'm just picking a point here somewhere. I'm going to just use a 4H pencil now, so a construction line. Drawing a line down to the base. Okay, so this point here will be 0. Okay, and to determine the circumference of this arc, we're going to step the distances from the circle, or the base, if you like, of the cone in the end elevation. So I'm just going to step any one of these distances because they should be all the same. So I'm taking 1 to 2. I'm just going to have a quick check to make sure 3 to 4, 4 to 5 are the same, which they are. And I'm going to mark off 12 equal spaces along this bottom arc. So this is 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and one more brings me back here to 0. And again, I'm going to index these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12, or back to 0. Okay? So in doing that, that finds the end, or the edge that joins on to this edge here. So I can join 0 to the vertex, and all those other points are joined back to the vertex or the center of the arc. I'm going to heavy in the line from the base to this point here. And over here. And I just see, can I darken those curved surfaces just a little bit more to complete the development of the truncated cone. Okay, so that's the development of the truncated cone complete. Each one of these lines are generators represented from the generators that we've drawn over here already. So you can see that the generators pass through the face that has been cut at points, and we can find those over here as well. People say that there's no need to draw in these lines, but for the purpose of this demonstration video, I think it's important to draw them in. Okay, so remember, it's always important when starting off drawing this arc that the radius is taken from your apex along a true length to find this point, and from the apex along a true length to find that point. I will complete the development of the cylindrical surface in the next video.